Hey Math 206, we are wrapping up section 5 on volume. So let's consider a pyramid that has the net shown here. So you've got a square base and it doesn't tell me what the height is, but I want to find the volume of what this pyramid would be. So first I'll need to find the base area and then the height of the pyramid. So the base area is easy because we've got a square. So the area of the base is 10 times 10 or 100 square centimeters. Now to find the height of this pyramid, let me first draw a three-dimensional model here. So here's my pyramid. First I'll need to find the height of this object. And in order to find the height, which I don't know, usually I use the Pythagorean Theorem. If I know what the slant height is, and I know what the distance here from the center of the base out to the square, if I know those two lengths, then I should be able to get the height of the pyramid. Let me call the height of the pyramid h. Now, of course, here I'm given that each triangle is, each one of these triangles is equilateral. So if this side length is 10, this is 10, and this is 10. Now that doesn't give me the slant length, the slant height of the pyramid. That gives me this distance here of the edge of one of my edges of the pyramid. So I'm going to need to find the slant height first. I'll call that L. To find the slant height, I will use the Pythagorean Theorem. L squared here plus, and now the length of one of these, each one of these triangles is 5 centimeters. So L squared plus 5 squared should equal the hypotenuse squared, so 10 squared. So that's L squared plus 25 equals 100, or L squared is 75, which tells me that my slant height L is the square root of 75. So now I can use that slant height here. This is the square root of 75. This distance from the center of the base out to the edge should be exactly half of the side length of the square, so that's also 5. So now I can find h by doing h squared plus 5 squared. That should give me the square root of 75, the slant height squared. So this is h squared plus 25 equals 75. So subtracting 25 from each side and taking the square root, we get that the height of the pyramid should be the square root of 50. So now I can finally calculate the volume, which is the base, 1/3 the base times the height. So it'll be 1/3 times the base times the height, or 100 root 50 over 3 cubic centimeters. Now, of course, if this were an application problem, I would use decimal approximations. 100 times the square root of 50 divided by 3. That gives me approximately 235.7. And my units, again, are cubic centimeters. So this was quite an involved problem. It looked easy to begin with, but it turns out we needed to solve several different things along our way to solving this problem. All right, the last formula that we want to discuss is the formula for the volume of a sphere. So first I'll give you the formula for the volume, and then I want to discuss where it comes from. So the volume happens to be 4/3 pi r cubed. All right, so the where this comes from is, imagine that you have the sphere that is all filled in, approximated by these cones or pyramids with the apex centered at the origin, and whose base is approximating the surface area of the sphere. So the volume of each one of these is 1/3 times the area of the base, I'll call that B, times the height of the pyramid, which is approximately the radius of the sphere. Okay. So now when you add all of these up, suppose you have n of them that cover the entire sphere, that'll be 1/3 times n copies of these pyramids times B times R. And now you have n of these that cover the sphere and n of these bases, and the bases are approximating the surface area of the sphere. So here, NB, this is the surface area of the sphere here, which we calculated in the last section to be 4 pi r squared. And then you have this extra factor of r being the height of these pyramids. So that's 4/3 pi r cubed. And again, I can't justify for you this 4/3 pi, or this 4 pi r squared being the surface area of the sphere, because that's a little bit beyond us. But once we know what the surface area of the sphere is, we can just use these elementary methods to figure out what the volume is. In practice, here's how that looks. Let's find the volume of a sphere whose radius is 6 inches. The volume would be 4/3 times pi times 6 cubed. And then our units here would be cubic inches. All right, so then calculating this, we get, this should be equal to 288 pi cubic inches. And of course, in practice, you would take that 288 and multiply it by an approximation for pi. So pi times 3.14. We get 904.32 cubic inches for the volume of this sphere.